Hey, welcome back to Mr. PL's with Precal. This is Unit 2, Topic 2, Lesson number 2. So we're going to still solve log equations, but these are going to require quite a bit more work because we got to condense them down, and some of these are going to end up being exponential, which you'll see what happens. So this first one, so we have log base 3 minus log base 3. So we want to condense these two logs down to 1 because you can't exponentiate when you have two different logs. It needs to be down to just 1. Otherwise, it does not work. So remember our basic properties of logs. When it's subtraction, that means it's the same as division of the two x's. So this becomes log base 3 of x plus 24 over x plus 2 equals 2. Now from this, the inverse of log base 3 would be the exponentiate to the power of 3. So this power of 3 and this gets canceled out. So you're left with x plus 24 over x plus 2 equals 3 to the second power, which is 8. I'm sorry, 3 to the second power, the 9. Not 2 to the third power. So then I want to get this x plus 24 by itself. So I'm going to multiply both sides by x plus 2 times x plus 2. And that gives me, this times this is going to give me x squared plus 24x plus 2 more x's makes plus 26x's, and then plus 48 equals 8x plus 16. Now I want to set it equal to 0 so I can hopefully use zero product property. So I'm going to subtract 8x from both sides. So I get x squared plus 26 minus 8, which gives us 18x's. And then the 48 minus 16 gives us 32. All right, so now from here, and this might take me a second to think about this, so I need two numbers that are going to give me 32. Oh, it's 16 and 2. Okay, that was pretty easy. So x plus 16 times x plus 2. 16 plus 2 is 18. 16 times 2 is 32. Set them both equal to 0 and solve using zero product property, and that's going to give me negative 16 and negative 2. Now, it's very important that we check our answers in this case, and it looks like actually neither of them are going to work. The thing is, our answer when plugged back in has to be a positive number, so it can never be a negative. So if you plug negative 16 in here, actually we're fine, but if you plug negative 16 in here, we get negative 16 plus 2, which is negative 14. So that's actually an extraneous solution, because there would be no answer to this, because 3 to no power could ever be equal to negative 16. If you put x equals negative 2 in, so negative 2 plus 2 actually be 0. So unless I did something wrong, it looks like both of these are extraneous, like I said before, because 3 to no power can never equal 0. It has to be a positive number on the inside. So that looks like that doesn't work either. Very possible I might have rushed it, but I don't think I did. So the next one, we have a plus, which means it's multiplication. So we got to condense this down. So 1 log base 5 of x times x is x squared, and x times negative 4 is negative 4x equals 1. Then I'm going to exponentiate that to a base of 5. So this cancels out. I'm left with x squared minus 4x equals 5 to the first power, which is 5. Subtract 5 from both sides, set it equal to 0, and that gives me this. And then I'm looking for, it looks like it's this and this. Negative 5 times 1 and negative 5 plus 1 works. All right, so this answer ends up being 5, and this answer ends up being negative 1. Now, negative 1 plugged in here or here actually is going to give a negative, so that's actually an extraneous solution. If I put 5 here, we're good. If I put 5 here, 5 minus 4 is 1, and 1 works. It can be any positive number, so this is a real solution. That one does work. Skip that. So we do have a couple more problems here. So natural log of x to the 6. So in this case, the inverse of natural log would be e to the power of. So that's going to cancel here. So that's going to give me x to the 6th power is equal to e to the 12th. So in this case, if I want to solve for x, I would do the 6th root of both sides. So that's going to give me x is equal to e to the 12 6th power. Now 12 over 6 is 2. So it's really e squared is our answer. All right, so that one took quite a bit. So this one is base 5 and exponential. So the inverse of that will be log base 5. So I'm going to do log base 5 of both sides. That cancels out. Gives me 2x plus 1 equals log base 5 of 800. What power of 5 is 800? So as far as I know, that's irrational. So I'm going to leave it just the way it is. Subtract 1 from both sides. And that gives me 2x equals log base 5 of 800 minus 1. And then divide both sides by 2. All right, so that's going to be the same thing as, and this is going to be kind of a weird looking answer. So this is, dividing by 2 is the same thing as multiplying by half. So that's 1/2 times log base 5 of 800 minus 1. All right, so whatever that ends up being. You can put that in a calculator, and that's going to give you a decimal answer, but I'm just going to leave it like it is because that's a little more precise. All right, so this time we have, log base 5 of this. So, all right, so this is all technically one statement. So if I exponentiate that to the power of 5, so that's going to cancel out, give me log base 4 of x is equal to 5. I'm then going to do the exact same thing basically again and exponentiate to the power from 4. These cancel out, leave me with just x. 4 to the power of 5, 4, 16, 64, 256. I actually don't know the next one, so what is that? 4, 16, 64. Times 4 again is 256, times 4 again, 24, 20, 22, 8, 10, 1024. That looks like that's our answer. And that is going to work because that's going to be a positive, so that's not extraneous. All right, so this question over here. So, all right, so I needed a second to look at it. So I can change these all to base 5, as looks like the way to do it. Let me change colors actually so it stands out from the prior question. So 5, this is really 5 to the 1/3 power. That's 1/3 power is equal to 5. That's 5 squared, and 2 times negative x is negative 2x. Multiplied by 5 to the 3rd, plus there's also an x there, so that'd be to the 3x power. Okay, so anytime we're multiplying things with the same base, then you add the exponents. So that would become 5 to the x power is equal to 5 to the 1/3 power. Now, if the bases are the same, then x's must also be the same. So it looks like x is 1/3. So if I check that, so that becomes 5, and negative 1/3 flips it. So this is 5 to the 1/3 power. Well, I thought maybe I could check it in my head real quickly, but it's looking a little more difficult. All right, so moving to the next one. So I need to collapse this down. So this is a perfect example of what we started with, and this will be our last two. I got just enough time. Collapse this down by subtraction. So this is log base 2 of x plus 5, so quotient property, over x minus 1. Okay, so then exponentiate to the power of 2. So this cancels out, and you're left with x plus 5 over x minus 1 equals 4. Multiply both sides by x minus 1, because that'll cancel this out. So I'm left with x plus 5 equals 4x minus 4. I always move the smaller variables on both sides. It gives me 3x minus 4. Add 4 to both sides. Gives me 9. And then divide both sides by 3. It looks like x is 3. And just check to make sure that's not extraneous. It does work there and it does work there. So we are good to go. Last question. So condense it down becomes log base 2 of... It's addition, which means we're multiplying this times this. Now, this is differences of squares. So I'm 4 times 4 is 16. The outers is 4x. The inners is negative 4x. So those cancel. And then negative x times x is negative x squared equals 5. All right, so exponentiate. So cancel this out. You're left with 16 minus x squared. Okay, is equal to the 5th power, so that's 2, 4, 8, 16, 32. All right, so from there I can solve, and that gives me negative x squared equals 32 minus 16 is 16. Divide both sides by negative 1, and it looks like we're going to get... Sorry, I'm one step ahead of myself here. So that's negative 16, and the square root of that, so x equals the square root of negative 16, which is both positive and negative for I. So it looks like we got an imaginary answer on this one. All right, thanks again for watching, and look forward to the next unit. The next topic is on trigonometry. All right, have a great day.